Good morning, dear students. So today we have a very simple topic to be discussed. What is a resistor and how to find the resistance value of a particular resistor. So let's get started. So what are resistors? See, resistors, they are the materials that oppose the flow of the current. So, any material that opposes the flow of current through it can be called as a resistor. Then what is resistance? Well, it's nothing but the property of a material to oppose the flow of the electric current through it. Okay, so whichever material it tries to oppose the current through it can be said that it has got certain amount of resistance in it. So what is the symbol for a resistor? Well, this is the symbol for a resistor. So that is fixed resistor, and suppose if the resistance value in a particular resistor varies, then it can be represented as variable resistance, wherein you can see that there is a normal resistor symbol with a arrowhead. So that means variable resistor. What about the unit? The unit for resistance is ohms, and this is the symbol for ohm. Now generally, how do we find the resistance value of a wire? Okay, when I say a wire, it means a wire that conducts. Well, the resistance of a wire can be expressed as R is equal to rho L upon A, where rho stands for resistivity of that particular wire, L stands for length of the wire, and A stands for cross-sectional area of that particular wire. Alright, so now we have understood what a resistor is. Now, how do we find the resistance value of a particular resistor? Well, there are two approaches. The first one is manual approach by just seeing the color banding of that particular resistance, and the second approach is you can use a multimeter to automatically notice the resistance value of a particular resistor. Today we will try to understand how to find the resistance value of a particular resistance using the color band. Okay, so here we have just drawn the representation of a particular resistor. So you can see that any resistor has got some number of bands. Okay, sometimes the bands could be 4 in number, or sometimes they may be 5 in number. So suppose if we see that there are 5 bands, okay, color bands, which is being represented in this way: band 1, band 2, band 3, band 4 and band 5. So what do these individual bands represent? Okay, well, the first band, it says that it is the first significant figure of the resistance value. What about the second band? The second band represents second significant figure of the resistance value. What about the third band? The third band represents decimal multiplier for the resistance value. So please note, band number 3 represents decimal multiplier. Okay, so what is a decimal multiplier? We will try to understand by considering a practical resistance. What about band 4? Band number 4 represents the tolerance rating, which is expressed in percentage. Now suppose if the fourth band is represented by gold color, then that represents it is having a tolerance of 5%. Suppose if it is represented by silver color, then it indicates 10% tolerance. Now lastly, in band 5, okay, so band 5 represents reliability factor, which is also expressed in terms of the percentage, and it is based on 1000 hours of operation. Well, this is sequence of the colors that can help the students to remember the resistance value of a particular resistor. Okay, so this is especially helpful for the students when they are conducting their experiments in the analog lab and they are using the resistor values and they do not know what is the resistance value of a particular resistance. So they can just follow these particular colors and then note down their respective numbers and then just remember. Okay, so suppose if the band is in black color, then the number is 0. If it is brown, 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, and finally white is being represented by number 9. So for the students, just to remember, they can use this particular sentence. It's not mandatory. It is just a notation or a statement that can help the students to remember the particular colors and their respective numbers being associated. So it's like big boys raise our young girls, but violet generally wins. So what students can do is, suppose if they remember this particular statement, then they can just associate the first, letter of every word to that respective, color. Okay, so based upon this color chart, let's try to find out the resistance value of some practically manufactured resistors. Okay, so I hope students can see this particular resistor. Well, this has got 4 bands. The first band is brown in color, the second one is violet, the third one is red in color, and the fourth one, which represents the tolerance band, is gold in color. So let us try to find out the resistance value of this particular practically manufactured resistor. Okay, so right, so the first band, let me just mention it. So the first band is brown, the second band is violet, the third one is red, and the fourth one is gold. So this represents tolerance. Now the first band, because it is brown in color, its corresponding number is 1. The second band, which is violet in color, its corresponding number is 7. So let me write 7. The third band, which is red in color, its corresponding number is 2. Now this is the third band represents the multiplier. So it is 10 raised to 2. Okay, let me repeat. The third band, which is red, its corresponding number is 2. Now we had seen that the third band represents the multiplier. So it is 10 raised to 2. And finally, gold, it is having plus or minus 5% tolerance. Okay, so if I further solve it, then it will be 1, 7 multiplied by 10 raised to 2 with plus or minus 5% tolerance. So what is it? 1700 ohms with plus or minus 5% tolerance. So I can either say that it is 1700 ohms or 1.7 kilo ohms with 5% tolerance, plus or minus 5% tolerance. So what does this plus or minus 5% tolerance mean? Well, it means that practically, okay, when we try to measure the resistance value of this particular resistor, then it might vary either in a positive way or in a negative way with 5% tolerance value. Okay, so similarly, let me take another resistor which also has got 4 bands. Okay, so the first one is brown, black, red, and finally gold. So similar to the previous example, let me try to find its resistance value. So the first one is brown, first color or the first band. So for brown, the value is 1. Next, it is black. The second band is black. So for black, the corresponding number is 0. Then the third band is red, and based upon the chart, so the third band represents the multiplier factor. So if it is 2, then it represents 10 raised to 2. The fourth band, which represents the tolerance, is again plus or minus 5% because it is in gold color. So it is plus or minus 5%. Okay, so if I simplify it, then it will be 1, 0 multiplied by 10 raised to 2, which is 1, 0, 0, 0 ohms. Okay, so which is nothing but 1 kilo ohm. So this is 1 kilo ohm resistance valued resistor with plus or minus 5%, with plus or minus 5%. So that again means practically the resistance value of this particular resistance may vary from 950 ohms to 1050 ohms. Okay, because it is having a tolerance of 5%. Okay, now suppose if the tolerance, the color represented is in silver, then the tolerance would have been 10%. Okay, so we have two different colors for the tolerance values. Okay, usually the resistors are very reliable, so sometimes the fifth band will also be present, which represents its reliability factor. But in this case, we just have 4 colors being represented, wherein the first and the second one represent their numbers, the third one is the multiplier factor, and the fourth one is the tolerance band. Okay, well, so finding the resistance value of a resistor is pretty simple. I hope students have understood it. See you in the next video. Thank you very much.